In this video, we're going to talk about metallic bonding and properties of ionic compounds. So in bonds between metal atoms, the outermost electrons become delocalized or move freely. They're so far away that they are held very loosely here. So we've got all of these electrons that are so far away that what happens is it forms this sea of electrons. So if you notice, we have all these nuclei kind of sitting in this pink sea of electrons. So all of the positive metal ions are attracted to and held together by the sea of electrons. Let's move on to properties of these ionic compounds. There are 5 properties that we're going to go through. The first is a high melting and boiling point. So we have a very, very strong attraction between the cation, the positive cation, and the negative anion. It takes a ton of energy to move these ions out of their current state. That energy could come in the form of heat. So it takes a lot of heat to separate these. So because they have a high melting point, that means they're solids at room temperature. Ionic compounds are soluble in water. Soluble means that they are able to dissolve. So you've got water molecules. Water molecules are polar. So if you look at the drawing here, we have a positive end where our hydrogen atoms are, and then we have a negative charge here, or partial negative on the oxygen. The partial positive attracts the anion of the ionic compound. Remember, the anion is the negative end, and then the partial negative of oxygen will attract the cation. Remember, the cation is the positive end. So, of course, the negative is going to be attracted to the positive, the partial positive on the hydrogen, and the positive charge is going to be attracted to the partial negative on the oxygen. And what happens is this pulls the ionic compound apart. So again, because the negative end is being attracted to the positive end of the water molecule, and the positive end is being attracted to the negative end of the water molecule, it's ripping these apart. So that's how they're able to dissolve in water. Here's a diagram of what's actually going on. So if you see, here in this first picture, we have our salt crystal. Salt, table salt, is an example of an ionic compound. So you see that the water is pulling on various parts. So here we have the negative being attracted to the partial positive on the hydrogen, and we have a positive end being attracted to the negative on the oxygen, and it's going to pull those off of the compound. And we're going to end up with things like this. So those water molecules are going to dissolve our salt crystal here simply by pulling on the different charges. Third property we're going to talk about is they are not conductive as a solid, but conductive when dissolved in water. When something's dissolved in water, we call that an aqueous solution. So electricity is not conducted when the charges move from one place to another. So in the solid state, when the ions don't move, there's no electricity being conducted. So going back to that diagram of the salt, they were kind of in that square shape. They're not moving, so electricity is not going to be conducted. However, when they're dissolved in water, those ions are free to move, and that is how we have conductivity. So here's an example. Up at the top, you see we have this very rigid solid shape. This is the solid state. They can't move, cannot move. All right, when we dissolve them in water, you see that everything kind of gets jumbled apart. Okay, remember those water molecules are pulling the ionic compounds apart, and it jumbles everything up. So because everything's free to move, we have conductivity when it's dissolved in water. The fourth property is a crystalline structure. Ions are arranged in a repeating pattern. So it's going to go cation, anion, cation, anion, cation, anion, and so forth, forming layers. It's called a crystal lattice. So if you look on the drawing here, we have cation, anion, cation, anion, and it just kind of repeats in that pattern. Here is a close-up of what a table salt molecule would look like, sodium chloride. Okay, it forms these very rigid, square, crystalline shapes. And the final property is a little tricky to understand, but they are all brittle. and this has to do with the crystal structure. So applying pressure shifts the alignment of the ions, which results in the repulsion of charges. This is what's causing the compound to fracture. So if you look at this picture here, you notice on the left-hand side here, we have our positive, negative, positive, negative. And if you think about magnets, on magnets, if you have a positive end and a negative end next to each other, they attract. When you end up putting the same end of the magnet, so if you have two positive ends of the magnet and you put them next to each other, they repel. Same thing, if you have two negative ends of the magnets and you put them close together, they repel. So if I'm shifting down, if I'm applying pressure on one side here, if I'm shifting this whole side down, right, notice I end up with these two positive charges next to each other, these two negative charges next to each other, and this is what causes the crystalline structure to repel and break apart. And those are the 5 properties of ionic compounds.